This is the second session in our first module. I hope you feel more knowledgeable after the first session and enjoyed watching Sir David Attenborough as much as I did. How did you find the questions? Please remember to submit your answers as you progress through this course, as they contribute to you becoming certified as carbon literate by the end. This time, we are looking at greenhouse gases and the background behind the science of climate change. This session covers the basic chemistry behind greenhouse gases and where they are emitted from, an overview of the science behind climate change, and I will explore the impacts we are expected to feel from both a global and local perspective. Why is carbon literacy important to healthcare, and why should primary care be interested? As professionals, we are driven and guided by principles of reducing harm and improving outcomes for patients and our communities. Our duty is to help those in need, to reduce the burden of ill health and actively promote good health. Ethically and morally, we protect those most vulnerable and work in their best interests. Climate change has the greatest impact on the most vulnerable, both here and abroad. Climate change is a health issue as much as anything else. Changes to our behaviour will lead to public health gains, as we will see later on. It is increasingly recognised, both politically and socially, that climate change is one of the most important issues we face. There is no part of the globe that will be untouched, and no country immune from the impacts. The urgency, however, is being driven by the science, not just politics and values. There are financial implications of climate change. As we will see in the next module, there are significant financial savings that can be made, but more importantly, improved health outcomes. We want to do a good job for ourselves, our friends and family, and the patients and communities we look after. There is a sense of loyalty and pride. Research shows that there is improvements to staff recruitment and retention for businesses which show leadership on environmental issues. We can make real choices about how we can lead a sustainable lifestyle, practice environmentally sustainable healthcare, and lessen the risk of more damage from climate change. But we have to have the tools. Modules 2 and 3 help to explore the tools we need and start to put a plan into action. To start with, a few words about the language I will be using. From now on, in these presentations, I will use the term climate crisis instead of climate change. Climate change is no longer considered to accurately reflect the seriousness of the overall situation. This is because the period we are entering is a period of climate crisis, climate emergency, or climate breakdown. The effects are already being widely felt, for example on plant and animal life, in the mass extinction events in some places, and the loss of the natural world. The term global heating is more scientifically accurate than global warming. Shortly, we will see that the greenhouse gases form an atmospheric blanket that stops the sun's heat escaping back into space, and later we will see that the heating is uneven across different regions of the world. Although the term carbon emissions is not inaccurate, if we are talking about all the gases that warm the atmosphere, the term greenhouse gas emission recognises all of the climate damaging gases. I will spend some time delving into the detail behind the gases which contribute to the climate crisis and examine the range of gases used. We will see that we can combine these gases into a single figure for ease of comparison, and this is known as the carbon dioxide equivalent. The story of carbon literacy begins with the understanding of the main culprits. Those are the greenhouse gases. The Kyoto Protocol applies to 6 gases in total. This international treaty has been effective since 2005 and regulates the global emissions of the gases which contribute to global heating. The 6 are carbon dioxide, methane and nitrous oxide, and 3 gases collectively known as fluorinated gases, sometimes shortened to F gases, and consist of hydrofluorocarbons, perfluorocarbons and sulfur hexafluoride. Carbon dioxide is a molecule that consists of 1 carbon atom and 2 oxygen atoms. Methane has a carbon atom at the centre and 4 hydrogen atoms, while nitrous oxide has 1 oxygen atom shared by 2 nitrogen atoms. Not all gases are equal when it comes to contributing to heating the planet. This is where carbon dioxide equivalence comes in. A key aspect of a greenhouse gas is its global warming potential. This reflects how long the molecules stay in the atmosphere and their ability to absorb energy. For example, a molecule of methane lasts about a decade on average in the atmosphere, which is much less time than a molecule of carbon dioxide. But because methane absorbs much more energy than carbon dioxide, the global warming potential is much higher, about 25 times higher in fact. Other gases have an even greater global warming potential. Nitrous oxide is nearly 300 times more potent than carbon dioxide, and the fluorinated gases are even more damaging. For example, sulfur hexafluoride is over 22,000 times more potent. The propellant used in some inhalers has a global warming potential of 3,200. Each of the gases remain in the atmosphere for a different length of time. As a result, even very small amounts of fluorinated gases will be causing damage for thousands of years to come. Carbon dioxide, methane and nitrous oxide are all found naturally but are also made by man, whereas the fluorinated gases are only man-made. We can see the different global warming potential for each of the different gases. For ease of comparison, we convert them into a functionally equivalent amount of carbon dioxide, and this is the measure to compare the impact of all the different greenhouse gases together. This is a short activity to match the greenhouse gases with the activities that release them. The 12 activities are beef farming, cement manufacture, deforestation, aerosol propellants, landfill and air conditioning, transport, refrigeration, power plants generating electricity, coal, agriculture and inhalers. Please pause the video at this point to match them. Be aware that some activities generate more than one type of gas. Welcome back. How do you think you did with this activity? Carbon dioxide is probably the greenhouse gas we are most familiar with. We know it is generated from the burning of fossil fuels in either transport or energy generation. However, it is also released in the manufacture of cement. And an increasingly important area of carbon dioxide release is deforestation. Methane is generated from cattle and anaerobic breakdown in landfill. The change of land use, such as deforestation, can also lead to methane release. Nitrous oxide is released by agriculture, but can also be used as a propellant and is used medically as nitrous oxide. Fluorinated gases are used in air conditioning, refrigeration, propellants and the electrical distribution network. Inhaler propellants are important to healthcare, as we will discover in subsequent sections. We have seen some of the activities which release different greenhouse gases. We will focus on carbon dioxide for now and consider how much is in the Earth's atmosphere. Atmospheric carbon dioxide measurements are made by two independent carbon dioxide monitoring programs at the Mauna Loa Observatory in Hawaii. This research station is situated about 3,500 metres above sea level in a very isolated and remote location. The findings are reported as parts per million of carbon dioxide in the atmosphere. Over a year, there is a natural monthly variation in atmospheric carbon dioxide. This chart shows the time period from April 2019 to March 2020. The seasonal variation in carbon dioxide occurs because of the growth of plant life across the globe, reducing atmospheric carbon dioxide levels during the summer. The carbon dioxide is locked into the cells of the growing plants and stored as carbon. In the autumn, growth stops and the plants die, which increases the levels of carbon dioxide in the atmosphere over the winter period before the cycle starts again. This seasonal variation leads to the sawtooth effect, often seen when data from several years is displayed. Rather than relying on data from a single observation station, several are positioned around the world. They are situated away from local influencing factors such as industry or plant respiration. There are stations at the North and South Pole. The North Pole shows a higher variation as it is closer to the seasonal fluctuations from the vegetation cycles in the Northern Hemisphere. But all observation stations show the same seasonal variation and increasing trend year on year. Carbon levels have risen substantially since the Industrial Revolution with the starting of the burning of fossil fuels. There have been natural variations in the previous million years, but carbon dioxide levels have not previously exceeded 300 parts per million, and that last time was about 300,000 years ago. The current carbon dioxide concentration in the atmosphere continues to rise. In 2019, the average was 414 parts per million. How do we know that carbon dioxide levels and temperature levels are related to each other? This data is from a paper in Nature from 1999, and it shows the carbon dioxide levels from an ice core over the previous 400,000 years. The scientists calculated temperature data using the isotopic content of snow. The data shows an excellent correlation between the carbon dioxide level and the temperature. The carbon dioxide concentrations ran between 180 parts per million and 300 parts per million. As shown previously, our current levels are close to 420 parts per million. To understand how carbon dioxide and the other greenhouse gases play a part in heating the planet, we need a brief overview of the greenhouse effect. The planet receives solar radiation from the sun passing through the atmosphere to the Earth. Some of this energy is reflected back into space before it even arrives. That which does arrive is converted into infrared energy, which we feel as heat. Some of this heat energy is emitted from the Earth's surface back towards space. And it is these energy waves which bounce off the greenhouse gas molecules and back towards the surface. In effect, the atmosphere acts as a blanket around the Earth. By adding greenhouse gases, this blanket is getting thicker and so retains more heat. What is the difference between climate and weather? In 2010, a sketch on the Armstrong and Miller show humorously put together a short 60-second guide to tell the difference between the two. It's worth watching this if you can on YouTube. Weather is what happens from one hour to the next. This is expected to change. So, some days the sun shines, and other days it rains or snows. Weather will always vary from one day to the next. Climate is the average of all the weather changes over many decades. It can also show the extent and frequency of extreme weather events. It can show the patterns of changing seasons and how one decade or century is changing from the last. It is this which is changing, and at a rate and extent not previously seen. This animation, based on data from the World Meteorological Organization, shows the average world temperature since 1850. It is now nearly 1 degree warmer than it was before widespread industrialization. The global average temperature for 2018 was 0.98 degrees centigrade above the levels from 1850 to 1900, according to 5 independently maintained global datasets. We can do better than average global temperature and look at some of the details for different areas. Historic data over the last 60 years shows an important regional variation. This shows the globe is not heating evenly, with hotspots especially over the Middle East, Russia, Africa and the northern polar region. What is the scientific consensus on climate change? A scientific consensus represents the position generally agreed on at a given time by most scientists specialised in a given field. It results from scientists in different disciplines seeing their observations through research leading to the same conclusions. A scientific consensus does not mean that all scientists are unanimous, so disagreements can and will occur and are necessary for science to progress. It does not mean that the position is definitive. The consensus can and will evolve with the result from further research and contrary opinions. Currently, many disciplines covering fields as diverse as atmospheric chemistry, meteorology, geology, glaciology, oceanography, physicists, marine biologists, hydrologists, ecologists, data scientists, climate modellers and many others are all conducting research, and the vast majority come to the same conclusion. Climate change is occurring and greenhouse gases emitted by man's activity is the main driver. Outside of changing weather patterns, there are many other indicators of global heating. There have been falls in the volume and extent of sea ice, snow cover and ice sheets. There have been increases in air, land and sea surface temperatures. There have been effects on plants and animals with changes to seasons, with spring occurring sooner and summers lasting longer. Migration patterns of some species has changed with more northerly migration of various species. Tree and plant life can now survive at higher altitudes and closer to the poles. We are increasingly seeing extremes in weather patterns resulting in a change to the longer-term trend of the climate. Records are being broken across the world, whether in heat waves in Australia, or record-breaking hail in America, or flooding across the United Kingdom and Europe. The Intergovernmental Panel on Climate Change, known as the IPCC, was established in 1988 by the World Meteorological Organization and the United Nations Environment Programme to assess climate change based on the latest science. In 2014, they released a Climate Change Fifth Assessment Report, which showed that changes in many extreme weather and climate events have been observed since 1950. Importantly, higher temperatures lead to more extreme weather events and rising sea levels. These events are collated into three main categories: meteorological or weather events, hydrological or water-based events, and events influenced by higher temperatures such as wildfires. There is increasing evidence of the link between human contributions to changes in greenhouse gas levels and temperature extremes, heavy rainfall events, and an increase in extreme high sea levels in a number of regions. The global impact of the climate breakdown depends on the overall average temperature rise. Global heating of 2 degrees will have marked impacts on hydrological events such as freshwater availability or flooding, human health, more of which later, and the anticipated loss of wildlife species, as we have seen in Australia in 2020 from wildfires. The higher the temperature increase, the greater the impacts. In the next session, we will look at the vulnerability of different populations across the globe, the impact of the climate crisis on different countries, the anticipated impact to the United Kingdom, and better understand the Paris Agreement and the United Climate Change Act. That's the end of this video. Please complete the question sheet and keep until the end of the whole module.